Hello students. Uh, Today I am going to discuss another problem on fluid mechanics. The question is, consider a solid sphere of radius r and mass density is given by this expression. Rho is a function of r, rho naught 1 minus r square by r square, where r varies from 0 to capital R. The minimum density, the question is the minimum density of a liquid in which it will float. Minimum density of the liquid jot a sphere to ki koribo paribo, float koribo paribo. So let's proceed. Suppose this is our sphere. This is our sphere. This sphere is having a radius capital R, but its density is not constant. Its density is given as function of R. R is the distance from the center of the sphere. Rho rs, rho naught 1 minus r square by capital R square. This one is the density of the sphere. Here what is the minimum density of the liquid where it can float? That means it will just float in a liquid. Float means it will be in the equilibrium. When it is fully immersed, its buoyancy force will be balanced by its weight. That is, your buoyancy force to ki hobo, your weight jitu ase, weight to hobo mg, weight to your buoyancy force ki kori thakibo, balance kori thakibo t. Tia buoyancy force to ami kom pam. The buoyancy force we can write it as mass of the liquid displaced. Jetia I float kori thakibo tetia gotekhini submerged hoi jabo, ml into g, mass of the liquid displaced, and it is written as rho L. Rho L means density of the liquid and volume of the liquid displaced into G according to Archimedes principle. This is according to Archimedes. So rho L into VV you can write. Velocity of the body, it is equal to velocity of the body. Velocity of the liquid displaced is equal to velocity of the body. গতিকে আমি লিখিব পাৰো rho L, velocity of the body কিমান হ'ব? The volume of this sphere, এই sphere volume হ'ব 4/3 pi capital R cube into G. So this is our buoyancy force T. Now for mg, weight of this sphere, we need to find out this capital M, the mass of the sphere. For mass of the sphere, since its density is not constant, so what we can do, we can consider a spherical shell of thickness dr. Spherical shell of thickness dr. Let me take this as this one. Spherical shell of thickness dr at a distance r. And this distance is dr. So this is our elemental sphere at a distance r from the center of the sphere. So mass of the elemental sphere is equal to dm, can be taken as rho r into dv, where dv is the volume of the elemental sphere. Okay, now what is the volume of the elemental sphere? The volume of the elemental sphere is written as dv is equal to 4 pi r square dr. So mass of the elemental sphere can be written as rho r into 4 pi r square dr. So putting the value of density here, rho naught 1 minus r square by capital R square into 4 pi r square dr. Now if you integrate this, now if we integrate this, dm will get total mass capital M. We will integrate it from 0 to capital R, rho naught 1 minus r square by capital R square 4 pi r square dr. So this is rho naught, you can take it common, into 4 pi. Then we will have, well, we will be left with r square dr minus, it is from 0 to capital R, minus r to the power 4 by capital R into dr, integration from 0 to capital R. So if we integrate this, we will get rho naught into 4 pi. This will give us r square by 2 minus r to the power 4 r to the power 5 by 5. R. So this is r cube by 3 minus r to the power 5 by 5 r square. This will be equal to rho naught 4 pi r cube by 3 minus r cube by 5. This will give us rho naught 4 pi, it will be 15 3 5 to 5 r cube minus, that is 3 r cube. This will give us 8 rho naught pi r cube by 15 is the mass of the whole sphere. Okay, this will give us the mass of the whole sphere. Next is 2, and from this we have a buoyancy force of this one, which is buoyancy force T equal to rho naught this one. So now we will need to equate for minimum density of the liquid. For minimum density of the liquid, mg is equal to buoyant force. This is equal to mass is your rho naught 8 rho naught pi r cube by 15 into g is equal to buoyant force is your rho L into 4 by 3 pi r cube into g. Now pi pi got cancelled, then r cube got cancelled, g got cancelled. This is 3 5, this is your 2. So from this we get density of the liquid is 2 rho naught by 5. So minimum density of the liquid where this sphere can float, যদি float কৰিব পাৰিব, তাৰ এনসাৰটো আমাৰ আহি গ'ল rho L is equal to 2 rho naught by 5. So আমি এনসাৰটো কি পালো, so our final answer is option number 4, 2 rho naught by 5. Thank you.